Hi everyone. Today I'm going to talk about how to create a two-way ANOVA using SPSS. So if you check my YouTube channel, you might have seen that I posted another video, a separate video to that shows you how to fit a one-way ANOVA using SPSS. So this video is basically devoted to two-way ANOVA model using SPSS. So in order to fit a two-way ANOVA model using SPSS, first you need to have the format of the data set should be like this. That means you should have a one column that have your new response variable, and then you have two columns which corresponding to your two categorical variables. So here I have categorized the school variable into four levels. They are 1, 2, 3, 4, and gender also has two levels. They are 1 and 2. And here I have labeled these levels. So if you want to label variables in SPSS, what you do is just go to your variable view, and here under the values of your variable you can add the label. So as an example, here I put school 1 to the value which corresponding to 1, and if the value is 2, then it represents school 2, so on. And here this 1 means male and 2 means female, so I label that variable as well. So in order to fit a two-way ANOVA using SPSS, what you have to do is go to Analyze and choose General Linear Model, and over here choose Univariate. So then you will see this window, and as your dependent variable you should choose your response variable. So I am going to put score over here, and as your factors you have to choose these categorical variables. So in this example, these two factors are fixed factors, but there are some situations these factors are random factors. Then you have to put those factors over here as random factors. And at the same time, you might have seen that there are some situations that there are some continuous predictors as well. So we call those kind of models as ANCOVA, or analysis of covariance. So in that case you need to put those numerical predictors as covariance over here. Since I have only the fixed factors, I am going to put these two variables over here like this. Then go to model. Here I am going to fit a full factorial model. That means I am going to fit a model with both main effects of two variables and with the interaction effects with these two variables. But there are some situations that you have to only fit a model based on the main effects. That means you don't need to consider the interaction effect. So in that case you can build your own model by going to this build term option, and here you can choose the which type of term that you are going to build. If you are going to fit if you are going to build a main effect, then you have to choose main effect from here. Then you can put the school or gender or both if you want like this into this side. Then if you click continue and press OK, then you will get a model which only contain the main effects. And here if you don't want this intercept term, then you can uncheck this option. So basically in ANOVA models you don't need this intercept model, so I'm going to uncheck this option anyway. And here you can choose whether you are going to use type 1 or type 2 or type 3 sum of squares. So this is important in the sense that if the design is balanced, then type 1 or type 2 or type 3 sum of squares will give you the same values. But the problem arises when the design is unbalanced. That means for the number of observations in each level are not same. If that is the case, then type if you fit the model based on type 1 sum of squares, then you will get an incorrect result. So in that case, in order to get the correct results, you need to choose type 3 sum of squares. Okay, so here I'm going to fit a model with both main effects and interaction effects. I'm going to choose this full factorial option over here and choose continue. And here under this option there are some check boxes that you can select if you need these results. As an example, if you want to perform a homogeneity test, then you can choose this option over here. And if you need the residual plots or the spread versus a level plot, or you can, if you want the results of the lack of fit test, then you can choose these options. And there are some other tests also, heteroscedasticity test, Bruce-Pagan test. Likewise, if you want to test any of these things, then you can check these options. After that, you have to press continue. Okay, so now I'm going to fit the model, so press OK over here, then you will get the results. So this is my ANOVA output. So here you can see the type 3 sum of squares for each main effects and interaction effects. So this is the sum of squares of school, which and this is the sum of squares of gender, and here you can see the degrees of freedom for each main effects and interaction effects and error term. Also you can see this mean square values and F statistics. So based on this you can see, so first in this two-way ANOVA design, what you have to do is, if you included an interaction term, first you need to check whether this interaction term is significant or not, because basically if the interaction term is significant, then there is no point of interpreting the main effects. So the first thing that you need to check is whether this interaction effect is significant or not. So here you can see the p-value of this interaction effect is 0.329, which is greater than 0.05. so you can say that there is no significant interaction effect. So because of that, you can interpret the main effects. So here you can see the main effect of gender is not significant because the p-value is large, but you can see the main effect of school is significant because the p-value is small. So you can see there are significant main effects of school based on these results. So if you need to get the interaction plots, what we have to do is we have to go to again analyze, generalize linear model, and here choose univariate, and here under the plots you can give any of these variables as your horizontal axis. So I'm going to give gender as my horizontal axis, and as separate lines you need to choose the other variable. So I'm going to choose school over here. Then you need to choose add. Then you can see this gender times school. That means there's SPS is going to plot the interaction effect between gender and school. Make sure you have choose this line chart over here. After that, press continue. Okay. So you can see here the interaction plot between school and gender. So here you can see these first three levels, that means I think school 4, school 1 and school 3, they are basically parallel to each other. But the problem is that school 1 and school 2, so here I think this is due to the randomness of this data. That means this is due to the chance these two lines have intercepted, because otherwise you cannot see any significant non-parallel thing in this chart. So, and based on this test also you can see there is no significant effect over here. So clearly this crossing of these two lines or this intersection of these two lines are due to the randomness of the data. So you can just ignore that. So based on this interaction plot, what you can say is that the lines are almost parallel, so there is no significant interaction effect. So here you can see the main effect is significant for school, so you can perform a multiple comparison test for school. For to do that, what you can do is go to analyze and select general linear model and choose univariate, and here you have to choose this post hoc option, and after that you need to select the variable that you are going to perform the post hoc test. Since I am going to perform the post hoc test for school, I am going to choose the school like this. After that, you have to specify the test that you are going to perform. Since I am going to perform the pairwise multiple comparison test for all pairs, I am going to choose this 2 key option over here. After that, press continue. Okay. Alright, so this is the results of this multiple comparison. So you can see basically the school 1 is significantly different. The mean test score of school 1 is significantly different with the mean test score of other 3 schools, because the p-values are really small. So you can reject the null hypothesis that there is no significant difference in mean test scores between school 1 and, let's say, school 2 likewise. But here you can see there is no significant difference in mean test score of school 2 and school 3, because the p-value of this multiple comparison test is large, so you cannot reject the null hypothesis. Likewise, you can interpret these results. Alright, so this is about the two-way ANOVA. So I think I gave you a very simple interpretation of how to interpret this result. So if you think that this video is useful to you, just put a like on my video, and if you want to see more videos like this in future, simply please subscribe my YouTube channel. Thank you very much.